All right. There will probably not be anyone watching this, but maybe there will be a recording of this. So yeah, let's get started. Let's set up some context. So what I'm trying to do, there's this great open source project called Pyroscope. Let me pull it up. Pyroscope. Yeah, let's see. Does it work if I drag this stuff in like this? Yeah, I think so. Cool. So Pyroscope is this flamegraph tool. So you can do a performance measurement of your application, and then you get a nice little visualization like this. And this shows the percentages of time that your application spends in different functions. And this is written using the HTML 2D canvas. And it would be cool if we could have some sort of animation if you click on something like this. And I think, but I haven't actually tried it, that currently the rendering might be a little bit too slow to sort of smoothly animate from this state to say this state. So I think Steve is going to do some actual measurements of how long that currently takes. But in his early measurements, it looked like that might be, rendering might be something like 40 milliseconds or something, which is a little bit too slow to smoothly animate. So we're recreating this in Pyroscope, in Zaplib. So let's get rid of this. Let me see. Yeah. Okay. So all the streaming stuff is a bit of an experiment. I just want to see what happens if we do this, if it's fun at all. Oh, I should probably move myself in this corner, otherwise we won't be able to see any code. Okay, this is probably a little bit better. I hope that the text is big enough. I will check that later. Okay, so what do we have right now? So, oops, I think here we have it. Okay, so I'm in the middle of refactoring some code. So let's look at that. I was just adding a bit of documentation. Right, okay. So let's first look at what we have so far. Right, so we have this prototype, and this is what the prototype looks like. So we are reading some data that I hard-coded in the application for now. And this is what it looks like if we run it with our native macOS build. But the thing is, and yeah, it seems to work. You know, we do this. Note that every time we do this, we kind of render everything. So all of this is rendered on the GPU right now. The thing that is really ugly and annoying, though, is that there's all this text that sort of flows through. That's just sitting on top of each other. So that's no good. So what we're going to do first, and what I've been spending a bunch of time on now, is refactoring some code for rendering text in a way that, in this scenario, like the way that we're rendering things here, we can have like a ... ellipsis type thing. So let me first show what that looks like in a case where that does properly work. So in Big Edit, which is the application, sort of the original MakePad application, because Zaplib was originally a fork from the MakePad framework. It might be a little bit hard to see on the stream, but in any case, if you have like some stuff here, and if you then don't leave enough room for it, it now properly puts like some dots there. And if at some point you don't have room at all, they just disappear altogether. And that is exactly the behavior that we want. So first we had to fix some bugs for that because this wasn't completely working properly. And now I've been working on making this a bit more generic. So let's see what that looks like in the code. So what I've been doing is I've been documenting the different pieces of code that we have here. So this is all text drawing stuff. So let me just finish that first, because there's not a lot of it. There's not that many public APIs. So I just documented this one. So this is for drawing text in the context of our layout system. So we have this layout system that kind of behaves a little bit like divs in HTML. And so it creates this box and so on. But then we also have a function for drawing a string sort of absolutely positioned. So if you don't want to use the layout system, you just want to organize things yourself, you can use this one. So let's maybe document that real quick. Draw text using absolute positioning, not taking into, let's say on the next line, this does not use the lay system in Zaplib. And that also means that there's a bit of a restriction on the number of chunks that can be outputted, and that has to do with, let's see, where's this wrapping thing? Right. So where were we? Here. Only single line text. Oh, there we go. It's supported. This means that you can only use wrapping none. Well, it almost got it. Wait, how do I trigger that again? There's some shortcut for this. I just got... Okay, I don't remember. Oh, that's also not it. Go away. Okay. Wrapping none. Oh, okay. And wrapping ellipsis for text ins props wrapping. Okay. Good. Okay, so that seems good. This is just a private function, but let me just document this real quick. Evac jar for every chunk depending on this, basically. Returns the total width per chunk. Okay. Be rendered as visual boxes in the layout system so that they wrap properly when there is no more space available. For example, using... Oh, this is not at all... here, layout API, that's the one I meant. What is a typical... Oh, actually, we can look here. Yeah, exactly. For example, using CX begin wrapping box. Okay. Okay. Yes. Well, this is mostly self-explanatory. This too. Maybe measure width is a better name for this one. Okay. Yeah. Okay. Do we use this much? Only in the text editor right now. Okay. So let's see. So, okay. I think this is enough for now in terms of documentation. Yeah, that's good for now. We can add some more next time we get here. Okay. Yeah. Some text drawing functions. Okay. Oh, and let me first do format this. Okay. I don't think that was really necessary. Okay. Now let's have a look at what we have. Oh yeah. So this one I wanted to rebase on top of this. Oh, no, on top of the initial POC. So I believe that if we do this, no, one above that. So this, yeah, okay. So we want to rebase this in there. Okay, that does it. Okay, wonderful. Yeah. Okay, that is all very nice. Now let's actually use this. So I spent quite a bit of time refactoring this already, so we can now actually make use of this. So at some point, let's see. Let's get rid of some stuff here. Okay, great. Yeah, so I think that is in here right now. In the flame rectangle, we call draw string. And yeah, we have a bunch of options, and here we now want to say wrapping. We do a wrapping ellipsis. Okay, and we need to give it a width that is the maximum width. Might actually not even be that wrong. The -10 I don't think is really necessary, but basically this is what we want. Okay, let's see how that does. Flame graph example. Okay, now that looks a lot better. Ooh, the ellipsis is a little bit ugly. Ooh, and yeah, I guess it, oh my goodness. Freaking Copilot was exactly right, because we have like 5 pixels padding here, and if we also want 5 pixels on the other side, we need to, oh my god, that's incredible. Okay, how the heck did it infer that? Okay, I'm a little bit blown away. All right, well let's, okay, so that's better. The ... is very wide, so I tried doing the actual ligature, I think it's called, like the actual single character that is the ... character, but I couldn't get that to work. Like, it might not be present in our current fonts, so this will have to do. But this seems to work pretty well. Yeah, disappears completely if you don't have any space. yeah, this is pretty good. Okay. So what do we want to do next? So this is a good start. Like the colors are all botched. I'm just doing some silly colors. The hover state I'm not super happy with. The hover state should basically be the original color, but a little bit brighter. So I don't know if we actually have in our shaders. Okay, so let me look at our shaders and see if we actually, did we do anything more? Oh yeah, we did this. Okay, add wrapping to flamegraph. Add ellipsis to flamegraph. Okay, that's pretty good. What do we want to do now though? We could kind of split out the wrapping stuff into its own PR, but that's a little bit boring. I can do that later, not on the stream. Right. Yeah, let's figure out how to make the hover state a little bit nicer. Because we have this color, and ideally we can come up with a different color. Wait a minute. This could be nice. What if we say... well, okay. Ideally what I want to do is I want to take this color and on hover say I want to brighten it a little bit. Or darken. Like I don't know what will look better yet. But I want to do something like this. Brighten color. Right? The alternative is, if we can't make this work, is we could have like a hover color. That would be a bit more data to send to the GPU. So if we can just do this purely on the GPU, that would probably be a little bit nicer. And then similar for the down color, we probably want to do something similar. So let's see, what do we have in our default shaders? So we don't have too many functions here. Oh, we can convert between. That might be nice actually, because then we can just increase the value part of it a little bit. The other option that I was thinking about, that is maybe, yeah, I don't think we have any other color things. The other option that might be a little bit of a hack is to say, well, what if we just have it go all the way to white, but then we just don't go all the way there. We go maybe like 20% of the way there. So I can multiply this by 0.2. So let's just see what that looks like. And this is really something where it would be nice if we had like a live shader. This is great. Okay, that is a fun hack. Yeah, that's good. And then, okay, now the dark color is pretty ugly. So maybe, do we want to darken it slightly when you click on it? Like how do buttons normally work? Do we have, like if these buttons, do they have some, oh, actually we have our own buttons. Let's have a look. So we have our single button example. So here what happens is it becomes darker and it has a bit of this effect where it gets pressed down, so to speak. I mean, not really, it doesn't really move all that much, but the background has that effect slightly. Yeah, I mean, that's pretty typical, right? Like, yeah. Okay. Well, let's see how that looks like. So if we have this one go all the way to 0 and we do the same trick, oops, then let's see what we get then. That looks pretty good. Yeah, I like that a lot. Okay. That seems, well, it's a little bit weird if you then hover out. No, it's not too bad. Yeah, and what's more, we will actually do an animation on this soon, right? So Yeah, this looks pretty good. Let's see, yeah. Yeah, at some point we also want like a popover or something to show up when you hover over these things with some more information on each of these rectangles. Excellent. So yeah, let's see what we can do next. Okay, let's first commit this. So better hover and down colors. That seems like a good start. Okie dokes. So maybe we want to do the animation next. That would certainly be pretty exciting. So yeah, what do we want exactly? So what we had in Pyroscope itself, let me see if I can pull that back up. Yeah, here we have it. Okay, so what we have here is if we click on something like this, then this box becomes 100% wide, but it stays at sort of the same Y position, so that is unchanged. Oh, and if I click it again, it goes back. Okay, so I can kind of do this. So everything up here, like the whole stack, is still visible and also becomes 100% wide. And if I click again, it just resets it. But if I now click on something here, I guess, yeah, it will go there. And then if I click here, it will just completely reset again. So that is the behavior. So there's this notion of a particular rectangle that is active, right? If I click it now, it's active. If you click the same rectangle again, that makes it inactive. If I click any other rectangle now, that becomes the active rectangle. So we can, first of all, just implement that behavior in the exact same way as we have here. And then the next step, of course, would be to animate it. Let's also just do a quick comparison. Yeah, I mean, the text looks a little bit different. We can see if we can tweak that later. The heights are, it's all a little bit tighter here. So we can make it a little bit tighter too. But yeah, actually let's just quickly do a quick pass to make it a little bit tighter, and then we'll do that. Then we'll do that behavior. So we can have a constant saying what the padding is, and then this will be twice the padding. So let's just do that here. So right now it's 5, but we want to make it a little bit less, maybe like 2. Oh, and yeah, for these things you have to, let's see, can it pick up on that? Yeah, I think you have to give it an explicit, type. Okay, now it gets it, great. But really, we're working with F32s most of the time. Oh, right, so I guess it couldn't pick it up because we didn't plug it in here yet. So then this becomes 2 times, oh, padding. Great. And then we want it to be a little bit, oh, so we already had a constant for the level height. So the level is, okay, so let's make this maybe like 24. Is that good? Yeah, so this is really where live editing would be handy, but that's okay. We'll make do. Okay, it looks like maybe a little bit tighter. Okay, let's say 20, and then let's call it for this little pass that we're doing. Yeah, that seems pretty good. Okay, whatever, maybe it's 22. Okay, close enough. I'll just change it to 22 and not even look at it. Okay, padding and height. Great. Right, so now what do we have? We have this draw call, and we call these things spans. And at some point we want to say, well, this particular span now, is sort of the active span. And then the way that changes things is that span becomes 100% wide. And all the spans below also have to stretch accordingly, right? Like basically everything that is, in effect, we're hiding a bunch of spans. And we're saying the spans that are left, have to stretch sort of according to that. Another way to view it, maybe this is a better way to view it, especially if we're going to animate stuff, is that we're sort of zooming, right? So you can say, if a particular span is active, like let's say that this span, this runtime.gc drain is active, it's almost like we're zooming with this being sort of the left bound and this being the right bound. And then if everything kind of, zooms properly, then then we'll get the effect that we saw earlier. And of course, we have to make sure that the text kind of, moves along a little bit and so on. But that is really the right behavior, I think. And then we can also do like manual zooming with the scroll wheel and then panning around and things like that. And we can animate these bounds to say, we want to ease them into this position and then ease them back. Both of the bounds at the same time. So that is pretty nice. And let's see. So for the rectangles itself, okay, so I'm basically trying to decide if I want to do this as a pure shader operation, right? Because we could set a uniform on our shader and then we just have to change two numbers. And based on those, and those two numbers can just animate the shader. The problem with that is that the text is a little bit more complicated, right? Because the text has all these ellipses, calculations, and so on. And so we actually need to do a bunch of calculation for even deciding which text to show, which glyphs to show. And it might be possible to do that completely in a shader. But that's probably a little bit harder, and certainly is not something that we just have readily available right now. So it's probably fine to animate this by just re-rendering everything all the time. So let's start with that, and then we can see if we need to layer in some optimizations on top of that. Okay, so let's see, we can get rid of some things. We're mostly here. This is our data. Okay, so this is our main file, and this is like a single rectangle. So what we do here is we iterate over all of the rectangles and we call draw on them. And so what we can say in this first iteration is we want a left bound and a right bound for our zoom level. So, and then later we can do optimizations of like not even drawing a particular rectangle. Okay, well, the very first thing that we have to do, I think, is just not recomputing this data all the time, because that would maybe get a little bit crazy. So that's easy enough to just do at construction. So let's do that. Let's just start with that. So we will basically say when we have a particular event, oh boy, what am I? Oh yeah, I see. Am I already? Okay, there we go. Right, so we don't really need any of them. And we just want to say this, but on construction, we want to compute a bunch of data. So we just move this thing in there. So let's say self.spans is this. In fact, we don't even really need to say that. That will be the default behavior. So we'll say here that we have a bunch of spans. Okay. And then here we need to say self.spans is where we push these spans. Oh, did I not? Oh, whoops. Put it in the wrong place. Oh, I don't. Yeah, right. Okay, and then we have the colors. Yeah, so we can just stick those in here too. Bloop. Okay. And then here we say self.spans. Okay, so that should still work. Okay. Let's commit that. Pre-compute spans in flamegraph. Okay. So then the next thing is to do this zooming business. So let's just say that is yeah. Let's kind of define the concept of what zooming means, right? So we can say sort of we have a public struct zoom, and we can say like x min. Oh, great! That's a great suggestion. And then x, fantastic. Yeah, that is what we want. And so we will have some state, which is the zoom level. We actually want to implement a default for zoom. That is not trivial. So here what we want, so x min, the default 0 is fine, but for x max, we want it to be 1. Okay. So now we have a nice default. So now what we want to do, I think, is just pass this zoom stuff into this draw function every time. We can also derive a couple of things just since that's kind of nice. Sure. Yeah, why not? Great. Okay. Maybe not that one, because floating point numbers don't support that. Okay. So now we can just pass in zoom to this draw function. So we can say self.zoom. Well, before we do that, let's have some fun with zoom, right? Let's say that if we scroll, for example, that we increase or decrease the zoom level. So do we have something like that? Point to scroll, that's right. Scroll event. Okay, sure. Point to scroll event. PSE. So let's see, what does this thing look like? Whoa, whoa, whoa. What did it suggest there? That looked interesting already. No, that is not right. Sorry. Right, so there's sort of a scroll direction. Yeah, that seems right. Let me just quickly see if there's yeah. Okay, we called PS here. Okay, sure. Great. So yeah, let's just do something fun, right? We can just say that if we scroll down, actually, do we have Pyroscope? Oh yeah, we can't. Oh yeah, scrolling here doesn't do anything, but we have our performance tracing thing, right? Like if we just do a bunch of things, blah, 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 blah. Like maybe we can mirror this. Okay, so if I scroll down, we zoom in, and if I scroll up, we zoom out. So yeah, if I scroll down, the scroll position, yeah, so basically in that case, x min grows and x max shrinks. Okay, so we say self.zoom.x min. Let's start with that. Let's just add, yes, but no, it's scroll.y. It doesn't get that right at all. And then, what did it say here? No, that's also not right. It's fine. So we want to do this, but then we also want to have a bound on it. essentially we want, first of all, to make sure that they don't get like too close to each other, right? Like at some point, there's sort of a maximum zoom level. Yeah, maybe that is actually a better way to express it. Maybe the zoom is like an X offset and a width, right? That might actually be a little bit nicer. Because then we just have to change the width initially. And yeah, okay, let's do that. Zoom. And it would really be like a zoom and a pan, right? Okay, let's call it zoom pan. That seems like a better representation. And this X offset is still 0. Yeah, and width should still start at 1. Okay, that seems good. And then really what we want to do here is we want to say the width is what changes, and it decreases if we scroll down, which I think we'll have, yeah, I think this is right. And so really I think what we want to do is something like this, and then clamp it, right? So we want to clamp it. The minimum width, let's say, is 0.1, and the maximum width is 1.0. And then this number will be relatively large, right? Like compared to 1. So let's divide that by, say, 10. Maybe more, let's do 20. Okay. And I don't know if we in fact want to make it like exponential or logarithmic or like nonlinear. But let's try this first. Okay, so that is not doing anything. Are we even getting this? Oh yeah, of course. We're not doing anything with this yet. Silly. So let's just print this real quick, just so we know if it is actually doing something. That is not really, yeah, okay, so this factor is not really big enough. Let's make it 200. And I think it's also going in the wrong direction. Yeah. Yes, I want it. Well, you can't see what I'm doing with my finger when I'm scrolling. I think this factor is still a little bit, let's make it this, and let's have it go in the other direction. Okay. That seems better. Okay, once we actually render this, we can see how this feels. Great. So okay, let's do that. Let me keep this debug statement here for now. So now what we want to do is we want to pass the zoom pan, and it doesn't need to be a pointer. This will, the data here will be just as big as the pointer pretty much. So here we can say, yeah, zoom pan is a zoom pan. Okay. Right, so now we want to have the position and the size be affected by the zoom and the pan. Okay, what does that look like exactly? So the position will basically just be offset. I think, well, okay. Let's assume for now that we have an offset that is always the same, which is in fact the case right now. So yeah, the only thing that is really going to change is sort of the right-hand side of our zoom. Like we will zoom. Yeah, like the left-hand side will be the same, but the right-hand side will change. And that will have effects for both the position and the size. Like some things will just fall off of the screen if you zoom in too far. Okay. So essentially we will need to scale this X position by the amount that the width has change. Okay, so basically if the width is 0, that's the most extreme case, then everything will be moved off of the screen. So everything will be moved by the width of the screen in that case. And if the width is 1, then nothing changes. There's no change to the positions whatsoever. Yes. Does that sound right? That sounds about right. This math is always a little bit tricky. So let's see. Yeah, and then everything has to essentially move over. No. Yeah, so if width is half, then if you were at half of the screen size, now you will be at fully the screen size. And if you were at a quarter of the screen size, now you will go to half the screen size. Is that right? Yes, that is right. Okay, so we need to multiply this by some amount. Yeah, so I think we need to multiply this by just width. Is that it? Because when width is 1, this won't change anything. No, that is not right. Yeah, no, that is right. No, this is not right. We need to divide it by width, right? Because if width is half, then this thing will become twice as big. Okay, that is good. And then the size, I think, essentially works in a similar way, where you have, like, let's assume that the box is all the way wide, then yeah, I think we also need to divide that in the same way. Okay. This feels very silly. I don't know if I have like a good mental model about this. Okay, so this is not doing any. Oh yeah, so we also need to request a redraw. So we need to say request draw. All right. That is promising. Okay, that's roughly what we want, right? That is pretty nice. It still feels a little bit sensitive, and also 0.1 seems like too high of a minimum. Actually, we want to be able to zoom much further than that. So let's change that up. Let's add 2 orders of magnitude to our zoom capabilities here. Okay, so now, all right, okay, that's pretty good. I do think we need some sort of like exponential behavior here, because at some point it just goes like super fast, right? And then when you get here, it's like not as consequential when you just do a little bit of a scroll. Okay, let me do that real quick. No, let's not do that. This is kind of good enough. The other thing that we will need to do, well, okay, let's maybe start here. Well, let's see. No, let's also implement the offset. So that shouldn't be too hard. So if we drag, we want to basically change this X offset thing. Yeah, let's do that. So let's add an event. What is it again? I think this is a pointer down. Yeah, pointer move, in fact. Okay, that's a lot of suggestions. Which might actually be kind of right. Oh my goodness. No, this is not quite right. No, is it? Well, we first of all want to make sure that we only do this when we're dragging down. So let's see, what is that again? If we go to this pointer move event, what do we have here? Is over. Yeah, there is. No, I think we don't. Yeah, we want a. Oh no, that is right. Pointer move. Yeah, otherwise we would get a pointer hover event, I believe. Okay, I'm not entirely sure about this. Let's just see, I guess, what happens. Yeah, this is where it breaks down a little bit, doesn't it? The whole GitHub suggestion thing, Copilot. So really what we want here is when we start, okay, yeah, we'll have to do a little bit more work here. So when we start, yeah, okay, let's do something like this. We can say here, pointer down position. Actually, we should really have that at the framework level. At some point. Wait, I'm just looking at the wrong thing. Let's look, what are all the things? Pointer was moved. Yeah. So we should really track. Do we do this already? Like if I look at our WASM32 implementation. Yeah, no, we don't do this. Yeah, a lot of this stuff is pretty gross. We need to fix that at some point. Yeah, okay. That is a battle for another day. I should annotate this. I should annotate this a little bit. Set by, what is it again? Event hits pointer. Okay, that's the case for most of these. Rel also, yeah. App start even, I think, yeah. Okay. And I think I'm right about that. Yeah, in that case it sets a bunch of things. That's what I thought. Okay, that is a bummer. Let's just do that for the other ones too. Like, which other events do we have? Pointer up, same deal. Boop. Yeah, let's maybe just do it for all. Oh, that is it. Okay. So these pointer hover. Yeah, so there we have rel and rect, I think. Rel rect, yep. And then which other ones do we have this issue with? Pointer scroll, yeah. Yeah, then we also have a rel and a rect. And rel is just being set to absolute. Pointer out. Oh, that's also pointer hover. Yeah. Fine. Pointer up, pointer down. Yeah, so let's just scroll up. Pointer down. Yeah, that is a good comment. This one. Pointer down. Did we do pointer up yet? Okay, yeah, we did. Okay, great. It's just very confusing. Fine though. Okay, so here we'll say pointer down X. It's an F32 option, and when we get a pointer down event pointer down D. Yeah, amazing. Copilot for the win. Mouse button. How did it? Yeah, it's so funny. It's very close. Yeah, and then when we have a pointer up event, we want to essentially say this thing is none. We are resetting it. So then we can say here that we have traveled. Oh gosh. I'm not thinking ahead. Yeah, how do we do this? We do have some functionality for this kind of stuff. Yeah, let's do that. Okay. How do we want to do this? Sure, okay, fine. We will actually use this thing. Hits pointer, which we were talking about here. Right, so that needs a component. Yeah, okay. Okay, sure. So we say event.hitsPointer, we match, we pass it CX, we need to pass it a self.component ID, we need to pass it a rect, but the rect can probably just be self.mainView.getRect, sure. Sure, whatever. No, that is not right at all. That is more it. In fact, let's just copy these. We don't have a component ID yet, but that's easy enough. Okay, now we have a component ID. That's all we need to do there. When does this thing not return anything? It always returns something. Oh yeah, we need to put this in as some. Okay, that's fine. Good. Yeah. Let me think about this for a second. Yeah. Okay. No, this is fine. This seems like a fine way to do things for now. Let's get rid of these. We've moved those over. Yeah, we can even have the pointer scroll be in here. And then now what we have access to in this pointer move event is a relative position. Because now we're in event hits pointer, and per the comments that I added there. Yeah, okay, so now we have a relative position, and here what we want to say is this should be pointer start offset x, and they should be self.offset self.zoom pan .x offset. Oh, we called it x offset there. Let's call it like that. X offset. Okay. So now what this is going to be is the start x offset, which should definitely exist. So let's say if I love this. This is pretty good. No, I don't know if that is quite right. I think what it suggested here is actually, it should be dependent on the width, shouldn't it? Yeah. Yeah. My goodness. So yeah, what you really, I think it will need to become a little bit more sophisticated, because you can also drag while you're scrolling. And in that case, okay, this will have to get a little bit more sophisticated. But this seems to be a decent starting position. Yeah, so something like this. So let's rename this though to this. And this should be rel.x, something like this. I mean, I don't know if this is right. I think, oh god, who knows? let's just give it a shot. Let's see what happens if we debug log this. Okay. So we take this thing and we start dragging to our heart's content. Okay. So there seems to be something good, but it doesn't. No, that is not right at all. Well, let's just not do this for a moment. So we have our start offset, and that start offset really should be 0 to start with, right? Because this is 0 in the beginning. So let's also print that. And then what we're doing, yeah, this does seem right. Okay, I'm a little bit confused. Let's see. So if we do this, okay, now it's 0. Oh no, wait, we're not seeing this right. Okay, let's start over. Okay. So, yeah, it immediately starts with some large number, whereas that one is 0. So where does that come from? Like that relative number should be, oh, oh, I'm confused. Okay, we should use app start minus apps or something. Fine. Yeah. No, like this. Yeah, that's better. it's funny. I mean, we probably do need something like that in a moment, but before we get carried away, let's see if this works. So now that's better. Okay, so now, yeah, okay, and we become negative, which honestly is fine. Like, we don't really need to clamp this. Yeah, you can just move it off the screen, I guess. Like, that's totally okay. Then it will be weird how this behaves while you drag, but we can't really reason about that by just looking at numbers. We will have to see that with our own monkey eyes. Okay. Great. Yeah, we don't really need this. Okay. Yeah, so that should not be too hard, I would presume. So this is just an X offset. Right, so this is interesting because the width, yeah, like here we're thinking in terms of pixels right now. Maybe we should also reason in terms of fractions, because everywhere else we're working in terms of fractions with respect to the size of the canvas. Yeah, this is a fraction, this is a fraction. Let's add that. Fraction of the width of the container. Yeah. Yeah, this is no, that's not it. This is absolute level number, top level is 0, something like that. Okay. Okay. So, yeah. Oh no, I spilled some water on my keyboard. How does that even happen? Okay. That should be okay, hopefully. Just turn it off. Dry it off a little bit. Yeah. It's getting late. It's 9 already. Okay, let's see if this still works. Okay, hopefully. So, yeah. Okay, so that is not too bad. We just need to add a factor here. So we can make this like pretty small. Something like this. So if we removed the debug statements. Oh, well, what the heck. We will see this in a moment. Okay, so let's say that this is indeed a fraction of the total width. Yeah, then we go back in here and we apply that. So there's a similar thing happening, only now it is really shifting things left and right. So if our offset is 1, we will have to kind of add this entire number, right? Like this is what we represent. Yeah, this is the width of the container. And so I think what we need to do here is all of this whole business here. Well, okay. Yeah, so if it is 1, but then if we're also zoomed, that is where it gets interesting, right? Yeah, so I think what we need to do is add this to the offset. And here we say zoom pan.x offset. So yeah, that's what we add here. And then similarly to our width. No. We just have to offset things. We don't have to resize things. Yeah. Let's see if this works. Yeah, that is pretty much exactly what we want. Now, if we zoom in a little bit, that also still works, but it goes faster now, right? So that is what we want to avoid. Yeah, so that is where we need to divide by the width over here. Where do we have it here? So here we also, well, we have to multiply by the width, right? Because this speed, yeah, this will be self.zoom pan width. Yeah. The thing that is a little bit annoying about all of this is that if you zoom, well, maybe that should actually be okay. Yeah, no, okay, well, let's just see how it feels first. Okay, so we can do this, and maybe we need to scale this by the size of the window. That's, or yeah, of the container or whatever, which right now is the window. That would be better, because this feels a little bit weird. So let's do that. So where did we have that thing? Here. So let's just say window or like a view rect. And then here we're going to divide by size.x. That's probably better. Yeah, okay. So we want this invariant to hold, right? Where the moment I press my mouse down, I'm at a certain pixel, and that pixel should kind of stay under my mouse, at least in the x coordinate. And then, okay, if I zoom, then that still holds. Great, that is exactly what we want. Now it's going to be a little bit weird if I yeah, actually this works great. Huh. The thing that I would like, yeah, this, I mean, it's not super ideal, but it's kind of close enough. What I would like is for it to zoom around my cursor, right? Like right now, the left-hand side is what stays the same and everything else scales. So maybe instead of an X offset, we want like a like a center of. Anyway, we can do some computation there at some point, and we also still need to fix like the zooming at some point, just getting like crazy all at once. But roughly, this is pretty good. This feels pretty good. Yeah, I'm quite happy with this, I must say. So now it will become a lot easier to animate what we want, right? That's just a matter of when you click something, we set the scale to what we want, and we animate to it, and maybe if you pan during the animation, it stops in place or something like that. So that seems like a good goal for today, and then we can call it after that. So great, let's see, let's first commit this. Yeah, so we want to commit these things. So add to-dos for confusing behavior in pointer events. And then here, yeah, this is really panning and zooming behavior that we added. And add panning, zooming with mouse to flamegraph. Okay. Okay, so now the fun begins, really. Let's make ourselves an animation. So it should be fairly straightforward, because when we click on a particular span, we know the offset and the width, and so we can just set the zoom pan to those values. Let's do that first, and then we can animate it. So we want this handle function of the flame rect to actually return us whether it was clicked or not. So let's start with that. We have a flame rect event which is clicked and up, and yeah, okay, great. That is actually already what we want. So we can say if let clicked is this. This is not particularly efficient. Every time we click, oh my goodness, it just completely figures this out, except that this part is not correct. That is quite impressive, though, I have to say. That is quite impressive. Okay, so this should do it. Oh yeah, right. No, we get the span. Right. No, this is not exactly right. Yeah, we need to keep a little bit more information here. So when we draw a flame rect, I don't think we currently save the span that we drew it with. We don't even have to save the span. We can save an index, right? So, but the span itself is like so little information that we might as well just save it on there too. So let's just do that for now. That's the easiest thing. So we will say here, this was the original span. Yep. The span itself is also just, no, it is not like it has a string in it and so on. We don't want to be copying strings. Okay, let's just save an index, span index. So let's say that this is a use size, because that is how we index into things. So then here we, let's say, have a span index, which is a use size. Whoops. And then we store that on ourselves when we get this thing. Self.span index is span index. That is good. Then we need to actually pass that in. So we just pass in I. Okay. That's our span index. In fact, we can rename I to be, oh boy, there we go. Yeah, I did want, whatever. Something like this, right? Okay, and then we need to return that when you click. So here we have a clicked, and this needs to, well, we don't really care about down and up, so let's just get rid of those. But we do want to send a use size here. Yeah, we don't really care about the down and the up event. But then here with the clicked, we send the self. Okay, great, fantastic. Okay. And now we go back here and we actually handle that event properly. So now we have a span index. And now we can say, well, we have self.spans. And let's just factor this out. It's not really super necessary, but this is pretty nice. Sure, we can take a reference to that span. That is all fine by me. Okay. Let's see if this works. Let's see if we get the behavior from Pyroscope here. So if I now click this, oh, that didn't work at all. It did do something. Yeah, but it's not right. Maybe I forgot if, oh boy. Yeah, that is not quite right. I forgot what, so maybe these were not fractions of the width. Let's look at the actual data. I might be mistaken. Let's see. So how do we compute the span? So here, yeah, this does look like we normalize it. I mean, let's just print these spans. We can print all of the spans. There's not that many. We can print all of them after we initialize them. I think that does mean I have to add like some derive statements here. Debug, yeah. No. Don't need all of those. And we do want to take a reference here. Okay. So let's see. That does look right to me. That does look right to me. Yeah, so really what we want is if we click this one, we should end up sort of in this state, right? Like, and the text isn't correct here, that should kind of move over. But yeah, with our current behavior, that is where we want this to end up. So where do we end up? Because that does look mostly right to me. So yeah, let's just do a debug on self.zoompan after we set it. And let's click on the top one first. Okay, so that doesn't, yeah, right. So if we kind of do this, then this resets our view. So that one is correct. Now let's try this one. Yeah, that is just not quite right, but it doesn't feel wrong. Let's see. It feels like almost right, like it should just be like this. The width is correct. Oh. Do we do the offset in the wrong direction? Like in general. I think that might be the case, like it's moving it here. Yeah. Sure, I mean, I don't particularly care like which side is positive and which side is negative, so let's just do it like that for now, because everything else is working. All right, okay, that is correct. Okay, haha. Okay, this is pretty good. Yeah, let's also implement the behavior real quick for going back. Right, if you just click it again, it should reset. That should be quite easy. Well, the only thing that we don't do right now is like actively track. But we can just do something like this, right? We can say if we click something and it's exactly the same. Okay. Yeah, right. If it's this already, then reset it or something. Let's say new zoom pan is, yeah, sure, minus here, and then like if self.zoom pan equals new zoom pan, then we reset it. Yeah, wow, there you go. That is incredible. Sometimes it's just so spot on. Okay, great. Tuck, 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 tuck. Oh, this is very satisfying. Okay, so this is beautiful. I mean, there's a lot more to be done, obviously, but we're getting there. We're getting there. Let's commit this first, and then we will animate it, and then we'll fix up the text so it stays sort of sticky on the left-hand side. So let's say this is zoom, focus on rect when clicking it, fully zooming, panning, so it spans the entire screen or container. Let's add it as a comment also, actually. Yeah, something like here. If we already were at this zoom level, then just jump back to, Great. Okay, so this seems really good. Now we animate. So instead of this being a direct operation, or even this being a direct operation, yeah, like this thing here should be replaced by sort of a zoom towards, right? Like we want to animate this. So we have an animation system, but I don't think it is quite suited for what we want to do. Let's see, because we animate a couple of other things here. Oh wait, in flamegraph. So here, yeah, so animations in this animator need to be constants. But do they? No, I think you can, like here we define them as constants, but you can just pass in any animation. Yeah, so we don't need them to be constants. So we can just generate an animation on the fly and animate towards it. So let's just see real quick what that is going to look like again. We have this thing here. We click it, we want to animate to this, and we want to animate it back. Right. And then we need some notion of the animation is done now. And when the animation is done, we and also we want to be able to abort the animation if we are just moving it around. But really the state of this zoom pan should be kept by the animator, I think. Yeah, there will be a bit of... Yeah, there's a couple of ways that we could implement this, but that seems to be a good way. Yeah, sure. Let's just roll with it and see where we end up. So yeah, what we really have is, what we want is an animator. Let's start with that. So we had an animator. Let's call it the zoom pan animator, because we might want to animate other things later on. Okay. So this zoom pan animator will sort of hold this value. Let's start with that. So let's just say that we want to set the zoom pan. So if we want to set the zoom pan with a zoom pan value, so we won't have self.zoompan anymore. This is out. Bye. What we will instead do is we will say, well, we're going to set it in the animator. And I don't know if that is currently possible. To just set things. It should be, right? It really should be. So I guess the workaround here is to just have a very quick animation. And maybe that is just good enough for now. Let's just start with that. So we're going to play an animation, and we're going to make this animation very fast when we're just setting it directly. So let's just copy paste some other animation. So something like this. So in this case, we'll have an extremely fast animation, and we don't want to chain it. We want to abort whatever animation we had before. And we will represent these things as a vec2. And we say that at the start of this thing, we immediately want this to be set to this zoom pan thing. Yeah, and so, okay. Vec2, zoom pan dot x offset, and then zoom pan dot width, and that is that. And then we want to be able to get the zoom pan similarly. And we need to pass in a CX here. Okay. And then we get the zoom pan from the animator in a similar way. So this returns zoom pan. Oh, there we go. Yeah. Oh. Not that smart, are you? Okay, there we go. What? Also not that. Okay, that's better. So we say I don't want to. I think it's better to represent these as floats. That seems like a little bit better. This is just a little bit gross otherwise. Something like this. Oops. Yeah, something more like this. Okay. Yeah, and then what we can say here is we are going to return a zoom pan, and that, what did it suggest? Yeah, wonderful. Okay, here it totally gets it right. This is great. Fantastic. Fantastic. So then here, here we say self get zoom pan, and then here we say set zoom pan. with this thing. Bloop. And in both cases, actually, we need cx as the first argument. Okay. Let's see what else we have. Right, so all of these ones we will also have to update. That seems fine, that seems fine. So we need to set the zoom pan in all of these situations. So we can say let mute new zoom pan equals yep. And then here something similar. And then we say new zoom pan width is and then we say, oh, did it have a suggestion? No. Self.set zoom pan, new zoom pan. Okay, something similar here. Yes, and here we can just do self.get zoom pan cx.x offset. Great. That is all good. Okay. That seems pretty good. Okay, so this should still work. Oh, we have, oh yeah, so here we also do get zoom pan. Okay. Who? Oh, yeah, this is one of those annoying Rust things. It somehow can't figure this out. Yeah, in fact, we just need to compute this once. Okay, that's fine. Okay, it's still unhappy. Ooh. Oh no. It is quite unhappy. What is it unhappy about here? Right. So I guess if we... Oh boy, yeah, is this one of those things where... Oh, I said it like that. Okay, I forgot about that. Oof. Okay, so we can't dynamically generate these things. That is stupid. That is quite stupid. Okay, let me think for a second. How do we want to deal with this? Yeah, it really is currently built for static animations. Yeah, and if we don't make this static, let's see. If we make this something like this and then something like this, it might be unhappy with things like this, yeah. Yeah, this would be unhappy times. Because it doesn't, yeah, it needs something like this, and then here you would have to annotate it, blah blah blah. You would have to say here, oh, this is like static, and then that just sucks. And here you would have to do something like this. It just all gets messy. It all gets messy. Yeah, we don't want this messiness right now. Oh boy. Let's... maybe we should take another tact here. Yeah, let's stash these changes. Like maybe we still want to go down this route. this is a little bit unfortunate. We have to have a better animation system for cases like this. But what I'm thinking is that we can implement this animation a little bit more low level ourselves. So what we really want is we want a target zoom pan and an amount of time that we have, or really a target time that we want to be there at. Time left is also fine, I guess. Target time also works. Okay, we'll just pick one. We'll pick target time, I like that. So because we say target zoom pan, and then we have a target, so we have like an option of a zoom pan and a target time. And I think, how do we represent time currently in CX? There's like time, last event time is an F64. Yeah, okay, right. So we can say here that at this time we want to be there if this thing is set. And then we also want to say if we do not do any panning, we just we want to abort this thing. So let's just start there real quick. Like anytime we do any of these things, right, we just want to set this thing to none. Yeah, at this pointer down we don't need to do it yet. Pointer up we also don't need to, but here we do need to set it. Okay. Okay, so we have a target zoom and target pan. And then what we want to do is, if it's set, we want to animate towards it. And here, instead of just setting the zoom and pan, we want to set the target zoom and pan. And if this also becomes a little bit different perhaps. Okay, let's get there in a second. So here we say this is sum, and then we need a target time. So this is really cx dot, what did we just look at? Last event time, plus, and then like animation duration. Something like this. Yeah. Okay. Anim seconds, great. Hey, anim seconds, okay. So let's say that we want the animation to be like half a second. Then this will be 0.5. Okay. Okay, so that is that. Yeah, and here we can say, or if self.target zoom pan equals zoom pan. Okay, let's not worry about that. Too much trouble. Cool. Okay, so now in our handle function, we need to handle it. And we also here need to say, yeah, actually we don't need to immediately request a draw anymore. But we do need to request a next frame. And then if we get a next frame event, which we can check for here, event next frame, that is how we're going to run our animation. So here what we will say is like, do we have a target zoom pan? And if we do, we need to animate. We also need an animation start time. So maybe actually the animation time left is a better. Let's actually see how our animations work. Well, okay, let's first do this. If let some target zoom pan equals self target zoom pan, then we're going to animate. Yeah. So in our animator, we have a bunch of helper functions for easing and such. And this, oh yeah, this takes a time value that is between 0 and 1. Yes, that makes sense. So really what is nice to have is a start time and an end time, and then we can just see how far along we are. No, we even just need a start time, actually. Yeah, let's just make this the start time, and we have this constant already. Yeah, let's do that. So this is just our start time. And so we can say, let's t equals, yeah. Wow. Oh my goodness. Okay, sometimes CodePilot just completely blows my mind how it knows that. Yeah, this is exactly right. This is exactly right. Incredible. Okay, so now what we want to do is we want to ease both. We want to use this ease function. So let's get this a little closer to us. So we want a standard one. So we want, here we use, we can just use ease default. So that is fine. So we can say ease default, and then we can call .map on it. Yeah. Okay, that's fine. Right, is that how it works? Yeah, and then we get a number out. So, no, wait. No, what? Is it unhappy with this? Is this not a thing? Or is this... Oh, it's not a public function. Let's make it public. Yeah. Okay, so we want to say .map. Okay. Ooh, boy. Is that right? I don't think it takes a... I mean, it's pretty close. I don't know if that is quite right. We want to map t, and now we get a value. Ooh, what we also need is the original. We need to keep the original value, because otherwise we don't know that either. Yeah. So maybe at some point we should actually make a struct of this. That's okay. We can just hack it together for now. Oops, this should be in here. And then this will be .1. Okay. So, yeah, really what we just want is to map this thing. Okay, and now we know sort of how to linearly interpolate. So now we say self dot zoom pan dot x offset equals our target. Oh, wait, did it get it? Ooh boy, that is exactly right. My God, that is insane. Except that we don't have a lerp. I mean, it is. It's conceptually correct. It's conceptually correct. Yeah, we do have a lerp here. I think in math we do have a lerp function. So if I do, for example, this, let's see, math.rs lerp from slurp from lerp. Okay, from lerp. Yeah, we just have that for a few things. Okay, that's fine. Oh yeah, here. Oh yeah, that's just okay, sure. That's just in our vector library. Like if I do that, do something like this. Okay, we can't really. It's fine. We probably want a lerp function at some point. Let me just add it to the add Zaplib. Okay, so that's okay. We'll just copy this thing. Bloop bloop bloop. I'll just put it somewhere. Cell, yeah, like from it's F32. Okay, great. And then this now works. Does it? Okay, sure. Is it going to be unhappy? Yeah, sure. Okay, whatever. We'll just do F32 here, because at this point, yeah, we've subtracted some numbers already. Okay, and then we want to do the same thing for the width. And then here we do want to, yeah, we should probably actually just do this in our draw function, because we're going to have to redraw anyway. So I'll remove this and put this in request draw, and then at the start of our thing, we can do a little bit of logic. And then when t is too high, that is when we need to stop. So yeah, when t, okay. Right. So we basically want to clamp this, or we want to say min 1.0, and then we also say if t is less than 1. Yeah, oh my goodness, it got it again, exactly right. This is unbelievable. Copilot is sometimes just a genius. Sometimes it's totally wrong, but sometimes it's just exactly right. Yeah, this is what we want. Okay, let's see if it works. Let's see if it works. Yep. Oh my goodness. That is exactly what we want. This is very satisfying. This is beautiful. I'm so happy. This is so satisfying. And this is a debug build. This is not even a release build, and it's still super fast. And I bet that, yeah, with a release build, this will be even faster. Oh man, this is so satisfying. I could do this all day. Click, click, click. Okay, so let's commit this, and then we have to do the text thing, because the text should stick on the left-hand side here. And that shouldn't be too much work, I think, but will be a little bit of work and a little bit of thinking. And then I think we can call it for tonight. Yeah, this is so satisfying. Oh man, I could truly click this all day. This is so much fun. All right. Let's commit this, and let's do the text. Add zooming animation when to flamegraph when clicking rectangle. Very satisfying. Very satisfying. Okay, text. So we go to our flame rect, and let's see what this looks like. So we have our draw, and we have a position, and okay, so there's two parts to it, right? Because we need to move things over to the right so that they become inside the screen. But then we also need to decrease the ellipsis length, so to speak, by the same amount. So if we have an x position here that is currently negative, we need to increase it, but this will go down. And that means that this might actually become a negative number, but I think that will be handled properly, I believe. So really what we want here, let's see. So we have a negative number and we want to turn it into a positive number and add that. But if we already have a positive number, then we don't want to do anything with it. So let's say we want a variable at text x offset. We have a lot of offsets at this point. Now I think we can express this mathematically, but I'm just going to express this in the way that I'm thinking about it first. So we can say if rect pos is less than 0, then we want this to be minus rect pos dot x. Oh yeah, this should be dot x, so thank you. Else we don't want to do anything here. And then we add this to our x, and then we subtract this from our ellipsis length. Okay, that seems reasonable to me. Now let's see if this works. Okay, so now, it sticks, and then it ellipses. Oh my goodness, this is so nice. This is perfect. This is exactly what we want, and it just works perfectly. And if I click it, this is so good, guys. My goodness, this is so satisfying. This is pure joy. This is what happiness looks like. Okay. Well, on that note, I think we're going to call it for today. Let me commit that, and then we'll end the stream. Make text stick to the left hand side. Let me add one comment here. Stick text to the left hand side. Okay. Well, it's been real. This was a fun stream for me to try this out, and I think this was just the perfect coding session, because if you end on a note like that, you're gonna sleep well. So thanks for sticking with me, and see you in the next stream. I think I'll do more of these at some point. Oh, and my goodness, Ryan and Dimitri are here. That is amazing. I didn't follow chat at all, but hi guys, and yeah, I'll see how to integrate this properly into the Pyroscope open source code base. All right, see y'all.